Hi students, in this session I will try to explain the types of organometallic compounds. In previous session we already discussed what is an organometallic compounds and a nomenclature of the organometallic compounds. In this session we are study the type of organometallic compounds. First of all, what is an organometallic compounds? We all are know that metal atom directly bonded to this carbon atom is nothing but organometallic compound. Basing on the nature of this bonding between this metal atom and this carbon atom, they are divided into many types: ionic compounds, covalent compounds, and electron deficient compounds. Now coming to this ionic compounds, see here, these are the ions, some metals: sodium, potassium, lithium, bromium, mercury, zinc. Here sodium and potassium have highly positive charge. When it is combined with carbon atoms or alkyl or aryl groups, these have high positive charge. Before going to that, we will definition of the organic metallic compounds. The compounds formed when the negative charge of an ion, the hydrocarbon anion, is delocalized once a carbon atom in the aromatic or unsaturated ring is known as the ionic compounds. These compounds are insoluble in water. Non-polar nature. These solvents are non-polar in nature. Here have a positive charge. The metal atoms have a highly positive charge. That's why it gets electrons from the ligands. Why? Because to get the stability here. When compared to this, lithium and bromium has partial positive and partial negative charge. Here mercury and zinc, these are the less reactive when compared to this one. Why? Because these outermost electrons have follow Seydt-Arquette rule. It is stable. There is no positive charge here. These are the stable when compared to sodium and potassium. To get this stability, these ionic compounds are highly reactive. It depends upon the stability of the anions. The anions, to get this stability, these are highly reactive. Ionic compounds are highly reactive. This is the example of this ionic compound. Now coming to the covalent compound. Covalent compounds. What are the covalent compounds? The compounds in which the metal is bounded to the an organic part of normal 2 electron sigma covalent bond is referred as covalent bond. See here, what is the covalent bond? These metals have some stability. These are less reactive when compared to the ionic compounds. These are, see, examples of this covalent bond: diethyl lead and trimethyl cadmium and phenyl zinc. These covalent compounds are insoluble in water. Why? Because these electronegative differences in this metal atom and this carbon atom is high. That's why these are insoluble in water. These are the covalent compounds. Now coming to the electron deficient compounds. Electron deficient compounds. What is the electron deficient compounds? These compounds with less than 8 valency shell is referred as electron deficient compounds. Doesn't follow the octane rule. These compounds with less than 8 outermost valence shell has not fulfilled by the 8 electrons is referred as electron deficient compounds. These compounds with less than 8 valence, outermost electrons have less than 8. The shells are referred as electron deficient. Outermost orbital is not fulfilled by the 8 electrons. That's why these are electron deficient compounds. The deficiency of the electrons occur when a compound has 2 valence electrons for connecting atoms between them. This compounds offers high charge to mass ratio and have shortly polarized cations and gain polymeric structure. See this example of these compounds. These are partially diethyl magnesium. These are partially polarizable compounds. This is the electron deficient compound. See here another compound is transition metal organic compound. Transition metal organometallic compound. What is the transition metal organometallic compounds? These compounds in which a transition metals are bonded to the saturated organic compounds. What are the transition metals? D block elements are transition metal. The compounds in which what happened here? A transition center. Transition metals are bonded to saturated organic compounds. Saturated organic compounds. With more than one carbon atom, the same organic compound is termed as a transition metal organometallic compounds. The interaction of organometallic organic compounds and ligands between the orbitals occurs by using the suitable p orbital of this metal. See example of this one. The commonly formed organometallic compounds are ligands are alkanes. 2 electron donors, butene C4H butene 4 electrons donor in this. Cyclopentenes 5 electron donors. Benzene ring 6 electron donors. Transition metal organometallic compounds. What is the transition metal organic compounds? This transition metal are bonded to the saturated organic compound, either butene, pentene or ethylene, methylene, like that. Okay, this is the different types of organometallic compounds. What are the ionic compounds, covalent compounds, electron deficient compounds, transition metal organic compounds. Now coming to the classification of organometallic compounds. Now coming to the classification of organometallic compound. Organometallic compounds are classified depending upon the nature of the metal carbon bond. Basing on this nature of the metal, they are divided into two types. They are metal carbon ionic bond, metal carbon bridge bond. See first one. Metal carbon ionic bond. metal carbon ionic bond. See these elements: sodium, potassium, rubidium, cesium. See these elements. The elements under the bonds are most electropositive elements. These elements have bonds with organometallic compounds are most electropositive. These are most electropositive elements. In this bond, the stability of the anion, most positive electropositive means it wants to stability. The stability of the bond is the stability of the anion plays an important role for the formation of a ionic compound. Yes or no? These highly positive charges want to get stability. The stability of the compound is the stability of an anion plays an important role here. Important role. The stable anion experiences with this aromatic ring and unsaturated organic groups. Formation of, see this example, magnesium C2 ethyl diethyl magnesium. Cyclopentadiene anion. Here this anion is delocalized once and a ring fine carbon atoms. In this ethylene, the unsaturated, C5 here. The unsaturated alkanes are delocalized once on a ring. See like this, C5 ring. Like this, the electrons are delocalized once to get the stability. Okay. The next one is metal carbon bridge bonding. See these elements: lithium, beryllium, boron, magnesium, aluminium. These are the some elements. Under the bond are light electropositive from the organometallic compound. These are the highly electropositive elements. These are the light electropositive elements. These are the light electropositive elements. That's why what happened? If it is light electropositive means form organometallic compounds are light. Methyl lithium, for example, methyl lithium, dimethyl magnesium, triphenyl aluminium. These are the common compounds of the metal carbon bridge bonding here. Okay, here metal carbon ionic bonds elements have high electropositive nature. That's why the anions get stability. If it is a ring structures, because of their unsaturation, the electrons revolve around the circle. Here metal carbon bridge bonding. Here these elements are less electropositive, light electropositive elements. That's why it forms a organometallic compounds like methyl lithium, dimethyl magnesium, triphenyl aluminium. These compounds forms oligomers or polymers, and one compound has many compounds. Trimethyl lithium 4 times. That's why it forms a bridge-like structure. It involves in bringing of alkyls or aryl groups. See here aryl group, see here alkyl group. Metal carbon 2 electron covalent bond. In this bond, the elements under this bonds are considered as moving elements that are from the binary alkyls and aryls. See here, the elements under this The elements under this bond. What are the elements? Are considered as moving elements. Moving elements that forms binary compounds. What are the binary compounds? That are alkyl or aryl. Both alkyl and aryl. See, MRN. This is the metal. This is the carbon. Here, how many electrons are? How many compounds are formed? So many compounds are formed. See this example. See this example. In trimethyl aluminum, you will see bond is more polar when compared to BC. See here. Here trimethyl aluminum, dialuminum. Here aluminum carbon bond is more polar when compared to BC bond. Here methyl barium and methyl aluminum. Here methyl aluminum carbon bond is more polar when compared to the barium with carbon atom. This is the 2 electron covalent bond. These are the types of organometallic compounds. Another bond have metal has with multiple bonds, and metal carbon has 5 bonds with unsaturated hydrocarbons. That also we discuss. Metal carbon multiple bonds means alpha beta unsaturation, multiple bonds. Where it is formation, metal carbon multiple bonds. The formation of multiple bonds between the carbon, metal carbon multiple bonds. There is a multiple bonds between the, see here, phosphorus and vinyl. Here phosphorus is multiple bonds between the metal and the carbon. The formation of these multiple bonds between this carbon and metal, carbon and other group of the elements is uncommon. It exists only oligomers, polymers like that. Phosphorus and silicon for the, see this compound, there is a metal carbon multiple bond. Another one is metal carbon pi bonds with unsaturated hydrocarbons. The organic compounds formed by the, see here, metal carbon pi bonds with unsaturated hydrocarbons. Pi bonds here. Where it is formed, the compounds are formed by this type of bonding are cyclooctatetranes and cyclopentadienes. It forms a number of compounds with the reaction elements. Where it is formed, cyclic compounds, most probably it is formed in the cyclic compounds. This is the classification of organometallic compounds. If you like my video, please give a big thumbs up, subscribe our channel, encourage me, and comment me your doubts in my comment section. Thanks for watching. Thank you.
Thanks for